Hi, now we are going to see about shift register counters. In the previous section, we have already seen what you mean by shift register. A register that stores one bit of data at a time is called as a flip-flop, and that flip-flop is combined together in a serial or a parallel manner to form a shift register. Now you are coming to shift register date counters. Shift register counters are same as serial in serial out shift register. So it is same as serial in serial out shift register. Only difference is that output of the data register or output of the flip flop will be connected to the will be given to the input. Okay, output of the data or the flip flop will be given as a input to the register, so that you will be able to count the numbers or count the number of clock pulses inside the shift register. Okay, there are two types of shift register counters. Question will be asked, what do you mean, explain the different types of shift register. So this is shift register counters. The previous we studied shift registers, so don't get confused between these two. Okay, shift register counters are ring counter and Johnson counter. It is also, this Johnson counter is also called as twisted ring counter. Also called as IS there, okay, twisted ring counter. Okay, so the two types are ring counter and Johnson counter or twisted ring counter. Okay, now let's go for first one, ring counter. The figure, I will draw the figure first. Okay, you are taking a 3-bit data, so you are connecting 3 flip-flops that in a serial manner, D1, Q1, D2, Q2, D3, Q3. This is a synchronous counter, so you are giving the clock simultaneously to all the flip-flops. Okay, now ring counter. So whatever data, it should come in a ring manner. It should come in a rotated manner. That's why you are calling it a ring counter. So the data will come in a rotated manner. Okay, for that you are using a ring counter. In a ring counter. Okay, here I told you in the previous class there will be some asynchronous inputs, some other inputs in a flip flop to make the flip flop activated. So that inputs are called as preset and clear. Some ICs will consist of a preset and clear. Only with the help of that preset, only if you're setting that preset and clear, the flip flop will be activated. Otherwise it won't be activated. So that inputs are called as asynchronous inputs. Okay, here in ring counter there will be some asynchronous inputs should be given, that is preset, preset. Okay, the first preset will be connected in a singly it will be connected. Others, how many flip flops are there, they will be joined together to give a, they will be shorted to give together and will be given to a plus 5 volt, that is the voltage that we are giving for an LED. And in the down, all will be having a clear pin. Okay, CLR, clear pin, that will be shorted together to give a plus 5 volt. Okay, so clock are they Q1, Q2, Q3. What happens if you're presetting the data? This data, when you're presetting, that means when you're giving it a high and then coming to low, a 1 will be set over here. First you are giving the data to a high. It is a pin. It has only two states, either a high state or a low state. When you're presetting, that means data will be set inside the flip flop. A previous data or a pre data should be set over there. So when you're giving the data, when you're giving the switch in a high mode and then coming to a low mode, high to low, then 1 will be set over there. All the data's rest will be 0. This will be in low. Okay, so here the data will be, here will be 0, here will be 0. So what happens when the clock 1 is given, 1 0 0 will be setted. Now you are not going to change the preset or anything. Next you are giving the next clock. What happens, this one will be passing over here. this will be 1. So what happens, previous it was 0, this 0 will be rotated and given over here, this will be 0 and this is 0. So 0 1 0. Next again when you are giving another clock pulse, what happens, this will pass over here to here, this will be 1, this will be 0 and this will be 0. So 0 0 1. When you are giving another clock pulse, only the one that you have presetted will be rotating. This one will come to the initial position. See, sorry, it will be 1 1 0 0. So it will go on. How many times the clock you are pressing, that much the data will be in a rotating. So to store the data, if you want to store, if you sometimes the question is given, design a ring counter for 110. So what happens, 2 times you have to give the preset value. First time when you're giving, it will be 1, and when again a clock pulse, this one will be transferred over here, and again you have to give a high and low, and the one will be set it over here. So then rest will be 0. That's in a ring counter. Hope you understand. A ring counter is nothing but a basic ring counter. It consists of a shift register counter. It is a serial in, serial out shift register in which Q output of the last stages is connected back to the D input of the first stage. So this is the last stage. This is the last stage. Here the data will be connected to the, here the data is connected to the first stage. This is a ring counter. So next we are going for a Johnson counter. Johnson counter is also called as twisted ring counter. So what do you mean by twisted ring counter? If you are taking ring counter from Q3, Johnson counter will be taken from Q3 bar. That's all. I will draw the figure for you. Here there is no need of giving any preset. If you, here also preset and clear should be there. Synchronous counter. Suppose the question will be asking for 5-bit, then you have to go for 5 shift registers. 5 flip-flops should be there. Here it is also in a serial in, serial out manner. The output of Q2 is given, Q2 bar is given as the input. Okay, this will be plus 5 volt. All the others should be connected together and given to a another plus 5 volt. This is preset. And here clear is optional. If you want, you can give, other you can avoid it. Okay, clear plus 5 volt. Okay, the same manner what happens, okay, here what I came to say is that no need of preset in a separate manner. What happens, I will tell you. Okay, here no need of preset in a separate manner. All the presets should be connected together to plus 5 volt, and all the clear should be connected to given it to a plus 5 volt. Here no need of preset value. Okay, what happens over here is we have a clock pulse Q0, Q1, Q2. In the initial stage everything will be 0. Okay, when you are giving the first clock pulse, what happens, here the 0 will go here and become 1. This data will be passed and given to the first condition. So it will be 1 0 0. Okay, again when you are giving the second clock pulse, now it is 0. Q2 is 0. What happens, your connection is from Q2 bar, it will be 1. That will be given to a D0. So this will be moving to the second position. So 1 1 0. Again when you are giving the third clock pulse, it will be from 1 1 1. Okay, when you are giving the next clock pulse, what happens, this will rotate over here and it will be 0. This is 1, no? Q2 is now 1. You can see Q2 is 1, Q0 bar will be 0. 0, 1, 1. Again when you are rotating you will get 1, 0, 0, 1. It will be 0, 0, 1, and last when you are giving one more it will be 0, 0, 0. This will go on. When you are giving the next clock pin again it will be 0, 0. It will be 1, 0, 0, like that it will go on. So this is a Johnson counter or twisted ring counter. The data you are taking from the ring counter, you are taking the data from Q3 or whatever is the last Q value, present state, and here you are taking from the opposite state Q2 bar. Okay, that's the difference between a ring counter and a Johnson counter.